Welcome back! It is the end of the cycling season here in New England, but I intend to squeeze every last mile out of it before we enter the fall. So, part number 2, beat your ghost. This is a session at the end of the summer, and what I'm gonna do is I'm gonna see if I have improved my performance over time over the summer. For this, I'll be exporting the data from my smartwatch with the help of the Garmin app and the Strava app. You can retrieve the code from my GitHub repo, and we'll dive directly into part number 2. And for this, you're going to need to set up your environment. So you can check out the link in the description on how to get Python packages inside of MATLAB Online. That's the environment that I'll be using. And here you can see that I'm getting the help from my helpful friend Copilot to simply ask how I can get pip installed from the Python packaged authority, PyPA, in MATLAB Online. Let's get started. So I'm going to walk you through each of the steps of the code. This is the table of content. I'll not mention all the setup. You can find it in my previous video, but let's dig into the analysis from today. So let me click directly to move over here. I'm gathering some data from my Garmin watch, and here is the timestamp, the position in latitude and longitude, the distance, and so on. So you can see here the whole table with the enhanced speed and altitude, some preparation that is performed by this function, prepride, and checking out if I'm moving or stopping. I stopped only once, as you can see, been pretty up for it this time. And here is the altitude. So it's not, it's a pretty flat road. So the part of it which is analyzing the grade here, which is a percentage of the rise over the run, is fairly small, as you can see. It's varying a little bit, but it's not going to impact significantly the performance of my ride. So let's just look at a baseline set of metrics. Here, let's look at the distance, elevation, moving time, percentage of time that is stopping. And here you can see a nice box chart that can give you a sense of my speed in kilometer per hour, depending on the grade. So as I mentioned here, I'm not seeing a big impact on the speed because, I mean, I've mostly been performing here on a flat terrain. So now let's dive deeper into the most interesting part of the tutorial. It's the estimation of the power, and if you don't have a power meter, you can estimate it. So this physics-based approach is good enough for a trend and giving us some indicators about my performance. So for this model, we'll be using aerodynamics, the rolling, resistance, the gravity, and inertia. So that's it. Let's estimate the power. And here is a curve that just estimates the power in watts over the period of an hour of my ride. We have a set of normalized metrics here, normalized power, NP, FTP, the functional threshold power, that is a best effort for an hour of effort. Intensity factor, how hard the ride was relative to my functional threshold power, and also a training stress score. Those are pretty usual metrics when assessing the performance of bicycles. So let's look at the power duration. So the idea here is we're going to be constructing a power duration curve, and that will enable me to assess the performance of the different parts of my cycling. So on the x-axis, you'll see the duration in seconds, minutes, up to 1 or 2 hours. And it's going to be broken down into different segments. The sprint, 5 seconds, 15 to 30 seconds, it's the anaerobic. 1 to 2 minutes, it's hard VO2 max effort. 5 to 6 minutes, it's the long VO2 interval. 20 minutes, it's the threshold proxy. and the functional threshold power benchmark the 60 minutes. So we're gonna get here a max sum of all of this, and this is the power table that is concluded from all of this, and here is the power duration curve. So with this, you should have a way of asking ChatGPT, how can I improve different parts of my power curve, and you can compute your own. So again, like, you don't need a power estimator, a power meter in order to do that. So now let's look at how I compare to myself in the past. We're gonna look at the table from the first ride, and looking at how it compares to end of June with the one that is the new one in September, end of September. And here we have a bunch of metrics to compare the two rides. So now let's simply look at the one versus the other. And as you can see here, that's kind of funny here, straight lines, vertical lines that kind of bias the analysis, because essentially if you look a little further, well, let's interpret all of this, and we're going to be looking at what's happening. So yeah, so I'm losing most of the time here when it's flat, and actually you'll see in a minute what is actually happening when I look at the diagnosis for pacing and fatigue. If I try to analyze here the decoupling, that is a correlation between speed and estimated power drops. So it doesn't seem to be correlating much. So let's try something else. Let's look at stops versus slow coasting. And here you can see that for the new end of September new ride, I've only stopped once, and I've been coasting a bit, like 16 minutes or so. It's not great. I guess I could improve there. Now let's do the same for the previous ride. And here you're gonna see, damn it, I stopped 5 times for the total duration of 5.3 minutes, and the coasting time is also not great. So if you analyze what's going on here, you can see that those are the areas where I stopped. And essentially, I remember now is when I was using MATLAB Mobile in order to set up the recording, I stopped quite a bit in order to record my ride. So that's what happened. Not blaming it on some excuses, but just kind of like an explanation. And here you can see it on a graph. I've been mostly pedaling, but then I stopped a whole bunch of time, and then I've been coasting, so I need to work on that part. All right, thank you for listening and following along. If you liked this video, feel free to share it and subscribe to my channel, and see you next time.